Hi, viewers, and welcome to the very first Anritsu Unplugged. My name is Linda Reinertz, and I am an integrated marketing manager at Anritsu. The purpose of this regular video series is to edutain you. What is edutainment, you might ask? Well, it's education and entertainment. We are so excited to kick off the series with our manager of our field application engineers, Danny Gonzalez. Danny has graciously agreed to be the very first guinea pig as we launch the series. I'd like to give a very sincere fist bump to Danny for being the very first one on the series. What are 400G ZR and ZR Plus optics, and how have they changed the way high-speed data interconnects are deployed in the field?
So that's a great question, Linda. And what we really want to look at are what are the applications that are driving the need for high-speed interconnects, right? And first, you want to look at what you hear in the news every day, right? You have artificial intelligence, you have machine learning, you have autonomous vehicles, and industrial automation, or the industrial 2.0, right? And what these applications are doing is what was traditionally located in a centralized data center environment where you had all the high-speed computing resources in one location has now been broken up, and it's been diversified and pushed out as far to the edge to the applications as possible, right? So instead of just one centralized data center, you now have dozens or hundreds of these smaller high-speed computing resources that are all being pushed out into the edge closest to where these applications are located within a city environment. Now, all of those individual high-speed computing resources all require interconnections to one another. And that's where the 400 gig ZR and ZR Plus starts to come into play. So those high-speed resources are all interconnected using 400 gig and 400 gig ZR, and then 400 gig ZR Plus, as we'll talk about in a moment. So what's first? We started with the 400 gig ZR standard, and that standard was originally created by the Optical Internetworking Forum, or OIF. Now, the original intention for this was to provide 400 gig coherent optics to travel anywhere between like 80 to about 120 kilometers, right? Then you started seeing the addition of enhancements, or ZR Plus and then Open ZR Plus. And the idea behind those was to be able to go even greater distances, but they were still derived from the original OIF 400 gig ZR standard. Now, the differences between the two, ZR versus ZR Plus, is the forward error correction, or FEC method that's being used in those optics. For 400 gig ZR, it's using CFEC, whereas you see in ZR Plus and Open ZR Plus, you're seeing OFEC. And really where those come into play is determines the amount of distance in which you could go based on those FEC methods, which we'll get into a little bit later. The variants of 400 gig ZR and ZR Plus also has additional enhancements to that of ZR, such as client interfaces, being able to support not just 400 gig ZR, but being able to support 100 gig, 200 gig, and a variety of different clients, which really comes in handy for service providers who need a little bit more flexibility than what was originally offered in 400 gig ZR. Now, 400 gig ZR Plus, as well as the Open ZR Plus, with all going into coherent optics, is that they're also able to be compatible with existing ROADM networks. And ROADMs allows for these coherent optics to traverse across these networks and be able to interconnect with one another. So that's fundamentally the differences between that of ZR and ZR Plus and why they're needed in the latest generation of high-speed interconnects.